Hello? Is it on? Yeah, perfect. Cool. So yeah, now it's 9:30, or maybe a minute after. So let's kick this off. Welcome to PodCon Sweden. It's been a couple years. It's going to be super exciting. Christine, I don't know where you are, but I think we should give her a round of applause again for organizing this and get this going. Where is she? I think she's in another room, setting stuff up. But yeah, we're going to start our first keynote now. This is Julien Simon. He comes from a very well-known group right now. I'm pretty sure you've all heard of it. And I think if you haven't heard of it, you will definitely hear of it today,
I think
also
so.
in the future. It's called the Hugging Face. And Julien, he is the chief evangelist of Hugging Face. Previously came from AWS. He was the tech evangelist for about 6 years, I'd say. And 6 years?
Yep.
Yep. And he was also the CTO and CTO, VP engineering, large-scale startups.
I forgot.
You got to go through the whole history. It's important.
It's boring. It's boring.
Yeah. So let's welcome Julien and
All
get
right.
this intro about Hugging Face. And let's kick this off. PyCon Sweden 2022.
Thank you. Good morning, everybody. It's such a pleasure to be back in Stockholm, one of my favorite places. I've been here so many times in my past job, and maybe we bumped into each other at AWS summits or dev days. If that's the case, hey, I'm still around. You know, we made it through those crazy years. So great to be in the same room again. So my name is Julien. I work for a company called Hugging Face. And who wants to do machine learning this morning? It's all right. We're not going to do any anyway. That's kind of the point, as you will see. So what I want to talk about today is how Hugging Face is making machine learning friendly and simple and fun, right? And for those of you who are not into machine learning at all, this might seem impossible, but hopefully in the next 50 minutes, I'm going to show you some interesting stuff, and then I hope a lot of you will think that, oh, I can actually do this stuff, right? I'm a mobile developer, a front-end developer, application developer, and I can do this stuff, okay? So that's why I'm here, to show you that machine learning is not reserved to the machine learning elite, which I'm not part of. I guess I'm a software guy, and I got into machine learning kind of by accident. And I can do this stuff. So if I can do this stuff, trust me, anyone can. So let's start with just a little bit of history on deep learning and why it's insanely complicated and annoying in its own way. So as we all know by now, I think, deep learning really means using neural networks, right? Ancient technology from the 1940s, if you can believe that, resurrected in around 2010, 2012 by research teams because of the availability of cheap compute, and applied to interesting problems like natural language processing, computer vision, speech, etc., etc. And I'm sure you've heard of those crazy architectures, convolutional neural networks, recurrent neural networks, long short-term memory networks. How could that be long and short at the same time? I never figured it out. Anyway, and these are crazy complex, but they work, and they've proven useful at building interesting models that can do NLP, computer vision, speech, and other things. Okay? But to get into that stuff is not easy. It only gets worse, because to train a deep learning model, you need a mountain of data, right? There's no real limit to how much data you can feed to a deep learning model, so most of your time will actually be spent preparing a huge data set, right? Labeling tweets, labeling entities in text documents, labeling images, labeling, cleaning, preparing, adding more. And if you talk to data scientists, they'll tell you anywhere from 50 to 80% of their time is spent doing that stuff, right? And they thought they'd do the clever machine learning thing, and they write SQL queries and Spark jobs, and that's not what they wanted to do. GPUs, of course, made deep learning possible. Like I said, 2012 and after. GPUs were never invented for machine learning, as we know. They were invented for 3D gaming, and that's okay, I guess. But they were actually put to good work with deep learning. That's fine, but as we found out in recent years, they're expensive. They're difficult to get by, although it's a little easier now thanks to the crypto crash. You can actually buy them by the ton if you're interested. If you're ready to go to, I don't know, China, you can buy a few tons of GPUs for a good price. But again, working with GPUs creates its own challenges. Like I said, they're expensive. They're power hungry. If you want to host a bunch of those in your data center, that's going to cost you a fair bit of money, right? And the worst problem to me is expert tools. And when I say expert, I mean machine learning expert. So if you want to get the accuracy that you want from neural networks and deep learning models, you need to go heavy into PyTorch code, TensorFlow code, and uglier things even. And you need a background in computer science and statistics and machine learning, and not everybody has that, right? And not everybody needs to have that. Unfortunately, that's the situation, and it makes it difficult for, I would say, normal companies who don't have a huge machine learning team to get really efficient with deep learning. And so a typical project looks like this, right? Spend a lot of time preparing your data set. Then hopefully you get to experiment and train your models and evaluate your models and build a POC to demo your models. And then hopefully you get to deploy that thing in production, but it's slow and you need to optimize it and you need to retrain it, etc., right? And the worst thing about this is, you've seen this picture many times, I guess, or a different version of it. It's a cycle, right? So it tries to make the point that it's agile, but it's really waterfall. Okay, it's data preparation for 6 months, training for a few more months, and then God knows how many weeks trying to deploy that thing with the appropriate performance level. And so that's not the right way. And well, I guess a lot of companies have proven it's not the right way because a lot of companies have failed to be successful with machine learning and deep learning. A lot of projects don't make it into production. Some POCs are never meant to end up in production because they're not good, but still, 87% is a lot. And, in the recent years, I've talked to a ton of companies, and actually very few have gone from A to Z with deep learning and created business value, right? So there's a lot of interest, there's a lot of excitement, there's not a lot of success. And I guess that's the thing we're trying to fix, okay? There's no fate. If you get that picture, thank you. If you don't, that's okay. And we think at Hugging Face, machine learning and deep learning can and should be as agile as software engineering. And there's a really good quote from a Google paper from a couple of years ago that says, don't try to build machine learning like the poor machine learning engineer you are. Try to build machine learning as the great software engineer you are. And I don't always agree with Google, but I think I agree on that one, right? And that's really what we're trying to do at Hugging Face. So we're trying to introduce a new way, faster, simpler, more efficient way to do machine learning and deep learning. And I'm calling it 2.0. Maybe it's 1.1. Maybe it's 1.01. We'll see. But it's new. It's different. And the main thing is, instead of having to work with that collection of crazy deep learning architectures, we tend to work more and more with transformer models. Okay, and we're going to talk a little more about transformer models, which is really the core of what Hugging Face is building at the moment. Okay, so the transformer architecture was introduced around 2018. I'm sure you've all heard about Google BERT, which was the first major transformer model out there. And as we'll see in a minute, transformers are now becoming a general purpose solution. So we can standardize our workflows with that family of models. The good news, another good news is we can stop or at least massively reduce the labeling and data preparation activity because we use transfer learning. Okay, transfer learning is a technique where you start from pre-trained models, okay, off-the-shelf models, which you can try as is. Let's say you want to translate text, or you want to summarize text, or you want to classify images. There are tons of models that are ready to go. You can use them in a couple of lines of code. Maybe they're good enough and you're done. If they're not, you can train them just a little bit more on your own data. Okay, and that's not a complicated thing to do, and it requires maybe 10x or 100x less data than you would need to train from scratch. Okay, so you go quicker to model training. Speaking about training, GPUs are still around, of course, but there's a new generation of machine learning hardware. Companies like Graphcore, Habana Labs, even Intel are introducing chips that have been specifically designed from the ground up to accelerate machine learning training and machine learning prediction. Okay, so that gives us just more options to build faster workflows. And last but not least, and that's our obsession at Hugging Face, we want developer tools. Okay, if you can write Python, and I'm guessing this room can do that, if you can write a few lines of Python, you're good to go. Okay, and this is what you will see today. You don't need to understand the finer points of PyTorch and TensorFlow. You don't need to understand the crazy world of statistics and deep learning architectures. You can just get the job done with simple tools. So transformers, as I mentioned, are eating deep learning. Transformers are quickly becoming the de facto solution for natural language processing, computer vision, speech, and generally all tasks based on unstructured data. So we can start to wave goodbye to CNNs, LSTMs, RNNs, and we say hello to this new family of models, starting with BERT and all the other crazy models for NLP and computer vision and speech, including our very own big science models, which is a large open source project that we co-led to build an alternative to GPT-3 by OpenAI. And so not a week goes by without a new model popping up and breaking new state-of-the-art ground and improving on benchmarks. And this was already picked up last year by the State of AI report and the Kaggle Data Science Survey, showing that transformers are generally becoming a thing. The 2022 Data Science Survey from Kaggle came out maybe a week ago, and it tells us that over 60% of machine learning practitioners use transformers, right? I think they had about 25,000 respondents. So it's not the whole machine learning community, but it's a good share. And so we can see this gradual rise in adoption. The State of AI report for 2022 also came out maybe a month ago. And what's interesting here, it shows the transformer modalities in research papers. So 2 years ago, as you can see, it was really NLP, right? 81% NLP, almost zero computer vision. 2 years later, NLP is still the largest chunk, 41%, but it's less than 50%, right? So we can see the crazy rise, for example, in computer vision and other modalities. So again, if you thought, oh yeah, Google BERT, NLP, that's what transformers are good for, well, that's the vision for it from 2 years ago. Now we have models for, I want to say everything, but not quite. Although, yeah, we do have a lot of models. And it's not just researchers. Those models are in production. So Google has been using transformer models for Google search for a few years now. Um, our good friend Elon is doing a real work, it seems, with Tesla and using transformers for computer vision. I don't know. Maybe you can use transformers to fix Twitter. I don't know. That'd be great, right? And yeah, you can get them for free too, right? Of course, all the voice assistants, Alexa and all the other ones are using transformer models. And we also see interesting use cases like Pinterest using transformers for recommendation, and generally financial services using transformers for a lot of tasks on NLP and others. So it's, massive industry adoption as well. So where does Hugging Face fit? So Hugging Face is a company started in 2016. We started building open source libraries for transformers around 2018. And as it turns out, we're one of the fastest growing open source projects ever. And I'm sorry if that sounds arrogant, but I think it's a fact. And if we look at GitHub stars, which is what you see here, Hugging Face is that starship on the left, the blue line. And it's crazy to see we grow faster than amazing projects like PyTorch and Keras, and we grow even faster than Kubernetes, which I still find mind-blowing, given the fact that everybody seems to be in love with Kubernetes these days. So a lot of adoption in the community, and that's great, and thank you everybody. If you've never looked at the Transformers library, now is a good time, and please give it a star. I think we're at 73K. We can always use more. And we also build a website called the Hugging Face Hub at huggingface.co. People tend to call it the GitHub of machine learning. I think that's a fair analogy. We all go to GitHub to find code and share code for our projects. Well, looks like we all go to Hugging Face to find models and data sets and share them. Okay, so good analogy. If you want to see some numbers, I checked this morning. We have 83,000 pre-trained models for NLP, computer vision, speech, reinforcement learning. If you're into protein sequence prediction, anyone doing that? It seems we have that too. 13,000 data sets ready to go, over 10,000 organizations sharing models and data sets on the hub, from Google and Microsoft and Meta, NVIDIA, to research labs, open source projects, and of course individuals. Day in, day out, we have over 100,000 active users on the hub, and we have way more than 1 million model downloads every day. That's an old number. I should actually look for the updated one. So it's a lot of traffic, and again, this shows the level of adoption that we have. So what is this for? Here's a simple example. I guess that's the basic example you could do on a Hugging Face. So here I want to classify a bit of text. Okay, that's a bit of text from Wikipedia. So what I'm doing here, I'm using the Transformers library, creating a pipeline which is an all-in-one solution to predict. The task type is zero-shot classification, which is text classification with a twist. And the twist is I can pass any arbitrary list of labels. Okay, I don't have to stick to text labels that are in the data sets. So if I wanted to score this thing on, I don't know, Sweden and whatever else, that's okay. It's not going to say, no, you can't use that label. I can score on anything. Okay, pass my labels, classify it, get my result. Right? So even if you didn't know what Python was all about, you would still understand what I'm doing here. Okay, it's the simplest way to use a machine learning model ever. And so you can grab all those NLP models and work like that, right? No training, no fuss, no machine learning at all. Grab the model, use it, add it to your app. Make your app smarter with that thing. Now, of course, that's NLP, and a lot of stuff has happened in recent years. I'm sure you've all heard of, maybe played with those crazy text-to-image models, DALL-E Mini, Stable Diffusion. Um, well, it kind of works the same. We can grab a pre-trained model for Stable Diffusion. We've actually built a dedicated open source library for those. It's called Diffusers. So load that model from the hub, just like that, and give it a text prompt and generate an image. And this is what I got. Okay. And people tend to think, oh, you cheated. You generated 1,000 images and you picked the right one, right? And I can promise you it's not the case. I think I ran a couple of prompts, and in 1 minute or 2 minutes, I kind of got that. Okay. And if you show this to anybody and tell them, hey, look at the picture I took, in the Nevada desert last week, I'm like, oh yeah, they're gonna. I mean, I tried it. You're gonna fool a lot of folks. It's pretty realistic. So that's kind of the state of the art with transformers right now. And it's amazing to me we can do this in 3 lines of code. So before we start looking at a demo and how fast we can actually go with Hugging Face, this is really the family picture. Okay, so instead of that ugly waterfall cycle, we suggest you do this. So you start from existing data sets on the hub, pre-trained models on the hub, and you can use them as is, as we've just seen, a few lines of code in the transformer library, and test the models on your data. If they're good, if you get the accuracy that you want, you are done. Okay? And you can call yourself a machine learning engineer, right? If you ever wanted that. Or you can call yourself a very, very smart developer, which I think is a better thing to be called. If you want to train those models on your own data, right? And I'll show you how to do that. Well, you can use, for example, the transformers library, right? And that's not a complicated thing. Fine-tune the model on a little bit of data. You could actually save yourself the trouble of writing any code by using AutoTrain. We'll take a look at that. AutoTrain is an AutoML service, and you just click a couple of times, and you have a state-of-the-art model fine-tuned on your data. Right? We have additional libraries like Optimum for hardware acceleration, but I don't want to give too many details, right? The main library you want to look at if you're starting with Hugging Face is transformers. Then you can actually move your model to spaces. I won't go too deep in spaces because my colleague Merve, where are you? Okay, she's here, is going to give a talk tomorrow, right? 11:30, I think. Okay, so don't miss that tomorrow, 11:30, if you want to see how you can bring your models and showcase them in really cool-looking web apps, right? And do really amazing demos for your customers and for non-technical folks. You don't want to miss that talk. And then, of course, you want to deploy the models for real, for production, and you can deploy them anywhere because it's all open source. Or you can use our service called Inference Endpoints, which lets you deploy on managed infrastructure on AWS or Azure. And we'll take a quick look. And last but not least, we have partnerships with AWS and Azure. So if you use SageMaker to train and deploy models, Hugging Face is already integrated there. And you can deploy from the Azure Marketplace on Hugging Face endpoints, right? And the only reason why Google is not here is because they don't seem to have my phone number. So anyone from Google? No? All right. Call me. Happy to work with you guys. Okay, so let's try and run something here. Here we go. Okay, is that large enough? Yeah? Yell at me if that gets too small, okay. So here's the Hugging Face hub. 83,949 models, right? Okay. And 13,000 something data sets, okay? As you can see, we have models for quite a few things, right? A lot of different tasks for NLP, a lot of tasks for computer vision, audio, multimodal, which is a complicated word to see. It's a mix of text and images and speech, text to image or image to text. We have some tabular data things going on, reinforcement learning, robotics. Okay, that's new. First time I see this. Okay, I'll check that one. Yeah, like I said, it's a little bit of everything these days. And so let's take a quick look at any one of those models, right? So when you click on one of those models, you see what we call the model page, and you have a model card, which is this text here that describes the model, gives you some samples, any concerns on bias and restrictions and evil that could be lying around in the model. You need to know about it, what data it was trained on, and the training procedure, and etc., etc. Right? You have all those nice tags that let you quickly see what the model is about. You can filter on those tags, etc. And you have the inference widget here, which lets you test. Oh, I'm a little scared, but every time I use that thing. All right, okay, that's safe enough. Yeah, generative models can be surprising sometimes. So you can try those models right away, get a sense of what they're all about. Okay, zero coding. If you want to use those models inside open source libraries, you have snippets. Models and repos are Git. Models and datasets are Git repos, excuse me. So you can clone those repos with Git straight from the hub and work with them. And we have shortcuts to train and deploy on different services. Okay, so that's what the hub is all about. So let's take an example. Let's say we want to train a model that can classify pictures of food, right? That's an important business problem to solve, right? So we need a data set. We need tons of pictures of food, right? So how would you do it? You could go and crawl Google for all kinds of food pictures and organize them, etc., etc. And that's boring, right? No one likes to scrape data sets. That never works perfectly well either. So we could say, do we have a data set for food? And as it turns out, yes, we have one. It's called Food 101 because it has 101 classes of different types of food, right? So lots of pictures and a label that tells me, okay, this is the type of food we're talking about, okay? And so we have 101 classes, and I think we can see all the types here, from apple pie to chicken curry to, okay, spaghetti bolognese and whatnot, okay. So that's a good starting point. We could say, okay, let's start with this, okay? Maybe it doesn't have everything we need, but 101 classes is not bad. So you could say, okay, how do I train a model on that? Okay, image classification is not a difficult problem. Okay, give it a picture, get a label. But now you're scared because you're thinking, oh no, I have to write PyTorch code and TensorFlow code, and that's not for me. I don't know how to do that. Well, I don't really know either, so that's the good news. So instead, we could go and use AutoTrain. Okay, and that's a really good starting point. So we can create a new project here. Okay, and just say, well, why don't we try this? Select the task type. It's the only choice you have to make. That's an easy one, right? So we want to do image classification, but you could do text, and you can do tabular data as well. You can let AutoTrain pick the models, which I think is a good idea. Create the project. And then you can bring your data, right? So if you have an image folder with your images organized, in usual way, one image per class, you can bring that. Or in this case, you could just say, well, why don't you go and pick that Food 101 data set, right? It's already split, so please bring the training set. The image column is this one. The label column is this one. Add it to project. Right? We can do the same for the test set. Right? Anyone can do this. Okay, that's it. All right, we brought our data. Go to trainings. Then it's going to fetch my data. That takes a few minutes. And then I can launch my trainings. Okay, so in the interest of time, I've already done that. And this is what I got. Okay, and there's nothing, I'm not hiding anything here. I just click exactly like I've done here. So I trained 5 jobs. Whoops, that's too big. I see my metrics, okay, accuracy, etc. So the top model was this one, of course, 91.45% accuracy, which is pretty good. And it's been automatically pushed to the hub, so I can view it on the hub, and this is the model here, right? And that page has been automatically built for me with my metrics and, you know, how many grams of CO2 that I actually generated. That's important. And I can test it. Okay, so why don't I test it on some food images? What do I have here? Let's see. Should have some images. Where is that? Yes. Oh, never mind. Okay, I can't find it. That's all right. I want to find my images. Oh, there we go. Can I do this? Yes. Okay. All right, so I can just drop an image here, and we can see the model is loading automatically. Okay, so it takes a few seconds, and we should see the prediction for this, right? So how many lines of code have I written so far? Exactly 0, right? Okay, that's the way I like it. Never write code if you can avoid it. Okay, absolutely, yes. All right, so let's wait for a few seconds for that model to load, and we should see the prediction. There we go, baklava, perfect, 99.8%. Okay, that's a good prediction. So that's pretty good, right? And we could go on and deploy that model for production. But then, you know, of course, someone is going to show up and say, what if I wanted the model to predict Swedish meatballs? Yes, I've done my research, right? Takoyaki, nope. I had to look it up. So apparently takoyaki is a kind of Japanese meal with, you know, like it looks like a meatball, but it has a, you know, octopus and something inside of it. So clearly not Swedish meatballs. Falafel, I could totally see why it would say that, but no, it's not falafel either. So complete machine learning failure. So now we could say, okay, well, you know what? Swedish meatballs is super important to our customers. We want to make sure we recognize those images accurately. So we need to have meatballs, right? In that model. So what would you do? Now, this time you have to go and scrape Google, right? And of course, there are tons of good pictures on Google. But no, we could try something else. Because remember, we have a way of generating images, right? Yes? I have to be the first guy in the world generating Swedish meatballs with Stable Diffusion. That's my, yep. That's my title of glory for the day. So why don't we try that? Whoops. See what it comes up with. Because that could be much simpler than, and of course we want lingonberry, which is not cranberry, as I'm told. Yeah, it's different. Oh, yeah, all right, that's all right. Let's see what it comes up with. You never know. Am I going to jail with this one? No? Okay. Thank you, Stable Diffusion. Okay, so let's try that. So that could be much, I mean, if we get decent pictures. Yeah, this one's weird. Let's try again. Which goes to show that if you want, I mean, the next top job in the industry, mark my words, is prompt engineer. Yes? This is the next $200K job. Trust me. All right, so let's give it a try and see what we come up with. All right, all right. Yeah, it's not too bad. It's not too bad. Okay. Oh, you don't call it sauce. Okay, thanks. Yeah, yeah, it's a good point. Yeah, because I was trying to find a way, because when you say sauce, it generates like US meatballs with ketchup. Okay. Oh, yeah, yeah, that looks a little better. Okay, thanks. Thank you. There you go, 200K for that gentleman. Thank you. Create a startup, my friend. So we can try and go that way, right? We could say, why don't we generate a bunch of images and train on that instead of scraping whatever website? So we can very easily do this. Okay, this is pretty much the same code you saw with the Corvette in the desert, right? Load the model. Okay, I don't want to go. Yeah, let me. Oops, nope. Yep, load the model. Okay, and then I wrote a simple function that just, that function will generate 4 images in a go, and that depends on how much GPU memory you have, right? So I can only do 4 in one round. So if I want to do, let's say, 100 images, of course I need to do 25 iterations. So that's what the function does. It just iterates as many times as needed, generates those 4 images, and saves them in a directory. Okay? And we can, yeah, so let me try that. Again, if it's running or if it's dead. Looks like my notebook's dead. That's okay. All right, these are some other images I generated. Okay? And so I'm going to go and, I could generate, 1,000 images in 1 hour, actually, with 1 GPU. Right? So pretty fast. I ended up generating 200 images only, because I'll be honest with you, I was running late this morning. And I thought, okay, let's go and train on those 200 images. So then, once I generated those images, the only thing I did, is, and I can show you this, I added them to the data set. Yeah, let's just go and grab a terminal here. Hello. All right, no worries, we can do it here. Or not. Yes, okay. Okay, so that's my original Food 101 data set, right? So 1 folder per class. So I just copied it and, created Food 102, right? And I added, oh, there we go. And we have Swedish meatballs, yeah? Okay, that's all I did. So it's not a lot of data set processing, right? Okay, so I did this, and then let me close this dead terminal. Yes, okay. And then I can just load it as a Hugging Face dataset like this, right? Just one line will load that full folder tree into a dataset, right? So thank you to whoever wrote this image folder thing, because it's super, super useful. Okay, and so now I have a proper Hugging Face dataset with 102 labels. My meatballs are still here. I can split it for training and validation. And I can push it to the hub, of course, right? One line of code. And now, if I look for that Food 102 dataset, it's here. right? It's here. Very cool. So now I have this data set, I can train on it, right? So why don't we do this? And well, I guess I could auto-train on it, of course, but you've already seen this, right? So now we're going to go one level deeper, and we're going to actually train the model with the transformers library. That's a little more involved, but it's not too crazy, I think. Okay, so import whatever classes are needed, load the dataset from the hub. Okay, one line of code, not difficult. I can see again the labels, right? I can grab the number of labels, the number of labels. I'm building dictionaries to map from one to the other. That's really useful because, you know, when you predict an image, you don't want to know that it's class 52, right? You want to know it's whatever actual text string that is, right? So that's that. And then I just grab the model that I originally trained with AutoTrain, okay, the one we tested. I'm going to train it for one epoch. So I'm just going to go through the data set, the Food 102 data set once. Okay. I should probably do more, but I was curious, you know, what I would get with just one round of training. Okay, some parameters for training. Then I load the original model. Okay. So my auto train model. I set the new number of labels, which is 102 right now. The mappings, and that's about it. Okay, then that's the bit I'm not happy about, but it can't be, I guess, ignored. Image classification models expect input data in a certain format, so we have to provide, you know, pixel values and labels in a particular format. So we need to have this PyTorch insanity in the middle here. But honestly, I copied and pasted it from our own tutorial, so you can do the same, right? And that's all there is to it. And it's generic, it's going to work for all those models. I just provide a metrics function to compute accuracy. So this one is simple. I pass the labels and the predictions, and it scores the accuracy on that. And then I define the training arguments, where I put everything together. Okay, so I'm training for one epoch and all my parameters, blah, 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 blah. Okay, and I want to push the model to the hub once I'm done. Okay, again, this is totally generic. I keep copying and pasting this from one notebook to the next. There's nothing specific to image classification. And finally, I define the trainer object, passing the model, the arguments, the data loading function, the metrics function, and the training set and the test set. Okay? And that's it. And then I call train. Okay? And it runs, in this case, on a single GPU, it runs for about 30 minutes, okay, which is not too long. You can do that many times a day. And so after 30 minutes, my accuracy is 91%. So it's a little lower than the original model. I'm not sure it's significant. I only passed 200 meatball images when all the other classes have 1,000 images. Okay, so maybe with 1,000 images I would actually improve, but okay, I don't think this is really significant here. All right, so now the training is complete, and I can push the model to the hub, right? And of course, if I go to the hub, I'll find, so it's one or the other. I don't know. Nope, it's the other one. All right, we need a wider window here. I can find it here. Yes, that's the one. Okay. And so again, this is created automatically for me. That model card is automatically created, okay, with my training parameters and the training log, etc., etc. And I get my inference widget. So now if I try the meatballs again, okay, I need to load the model. Suspense is killing me. Of course, I tried it before, but... All right, tells me Swedish meatballs. So at least, I've got this new class recognized, 29.8%. That's not a crazy high score. The next one is falafel, and again, that's probably the next closest thing. And it shows me that I should really have used 1,000 images, I think. And I should really find a way to prompt the model so that it generates something a little more realistic. Where is that? Yes. For example, this. Right? You tend to put the jam on the side, right? Yes? Not on it. Yeah, well, you put it on it afterwards, but you know what I mean, right? And my generated images, they look too much like US meatballs with ketchup on it. So I need to work on that. But still, this goes to show in very little time, you can actually, you can iterate on the model. And again, you could do this, in a couple of hours, right? Generating the images is an hour, 1,000 images in an hour. Training the model is, let's say, 30 minutes or maybe 1 hour if you want to do 2 epochs. And you could get some results, right? So in a couple of hours, you're getting some results, which is way, way faster than anything else you could try. And you could say, well, okay, no, my meatballs look too ketchup style, right? So, okay, let's reprompt, let's try something else. How would you query Google to say, show me meatballs that don't look like ketchup meatballs, right? I mean, no way. It's. I tried it. Yeah, I tried it. I tried it. I tried Swedish meatballs on the Stable Diffusion model. It didn't make a big difference. But you could try different things. And of course, imagine you wanted to add 50 classes of food, right? Like every Swedish specialty, right? You could prompt again and again and again and generate your data set very quickly. Okay? So that's an interesting way to do it. Now it creates all kinds of interesting questions like, when does this lead to mad cow disease for AI models? Because if you train those models on image that they generated, when does that go wrong? My guess is pretty quickly. So, because that's life. So what I would recommend, I think this is actually an interesting technique, but I would still use real-life images in the test set. I think it's okay to generate training samples. It's okay to generate training samples this way, but the test samples should be real, right? So go and scrape, 50 images from Google and test on those, just to make sure, the model doesn't get high on its own supply, so to speak. Because otherwise, you're going to get crazy good accuracy with the training, and then you try real life images, but they look different. So we still need real life data in there. Okay, so far we played in the notebook. So let's say you show this to your users, they're happy, and you want to plug that model into your mobile app for food recognition. Of course, you need to deploy for production. And that's a nightmare in itself, right? People invented a word for it called ML ops, Well, I call it ops, right? Deploying something in prod. But apparently, deploying machine learning models is so complicated, they had to invent a new word for it, so fair enough. If you try deploying your model, from your laptop to a production environment, there's a whole lot of plumbing you need to build on the way. And plumbing is just a waste of time generally. So we kind of built a service to simplify this. It's called inference endpoints. And again, it's a few clicks. So if I'm going to say food 102, okay, this is the one, right? Give it a name. Decide if I want to deploy on AWS or Azure, which we support for now. Let's do AWS in Ireland. We can select the instance type, CPU, GPU. The bigger GPUs are coming soon. We can have auto scaling automatically. And we can set the security level. So public means exactly that, means wide open to the world. Okay, no authentication. Protected means open to the world, but with token authentication. Okay. And private means not open to the world and only accessible through your own AWS or Azure account. Okay. I don't want to get deep into the cloud stuff, but typically for AWS, we use Private Link, which is an AWS service that lets you connect your private subnet to our private subnet directly without going through the public internet. So if you have compliance issues, healthcare, financial services, etc., this is how you want to do it, right? You want to deploy private models that no one can get to from the public internet. Okay, you click on Create Endpoint. It spins for a couple of minutes, and then you get your endpoint. Okay, so this one is a protected endpoint, meaning I have to pass my token to invoke it. So why don't we try this? Okay, so now I'm back on my local machine, right? We can close this thing here, right? I'm on my Mac. I'm passing the URL of that endpoint, my token, which is part of the setup in the Hugging Face account, and just a plain HTTP query. So let's try this. Okay, meatballs. Yes. Okay, well, same result, of course, same image, same prediction. Bam. Okay. So that's, I've seen lots of different ways to deploy models, including with my former employer. This is quite simpler. Okay, and what I really like about it is it's simple, it scales automatically, and it doesn't compromise on security. There are a lot of deployment services that are super easy to use, but you can't really get the privacy level that you want. And here you can achieve it very easily, right? So that's a good way to do it, inference endpoints. All right, I think that's pretty much what I wanted to show you. Maybe a few links to get started. So if you're totally new to transformers, the very first thing you should check is the tasks page, which Merve and our colleagues have built, our dev advocacy team. I love this page. It's all those machine learning tasks in plain English. And I really mean plain English, like no jargon. If you're completely new and you want to understand, let's say, zero-shot classification and all the weirder ones, that's where you need to go, right? And that's a good place to start because that's where you can see, oh, okay, yeah, this looks like a business problem I have. Okay, so I'm really looking for zero-shot classification models. Okay. The next step is to go through the Hugging Face course, and all that stuff, of course, is free. Forgot to mention it, but sounds obvious to me. And this course is, developer-oriented. It has a couple of deep dive sections on the sciencey part, which you can skip, right? I did. And if you just want to run code and understand those models and see them in action, understand deployment, the pipeline API, the trainer API, fine-tuning, blah blah blah, the whole story, you get that. With Google Colab notebooks and everything else. Okay, so very nice course. Whoops. Then of course you should take a look at our repos on GitHub and give them a star. Okay, and you'll be on your way. We have forums, we have a Discord channel, so if you can get your questions answered. And yeah, you just have to get started. If your company is interested in getting actively involved with us, we have consulting options, we have private deployment options. I don't want to talk too much about that today, but of course we can help you get up to speed and get your transformer models in production in less time than you would think possible. And last but not least, if you want to stay in touch, I'm still on Twitter, right? Waiting to see what Elon comes up with. Medium, YouTube, LinkedIn, etc., etc. Right? I'm generally easy to find. I'm more than happy to connect, and tomorrow, next week, next month, next year, feel free to get in touch if you have questions. I'm more than happy to help. All right, I want to thank you again for your time this morning. I want to give very warm thanks to the PyCon Sweden team for this cool event and for inviting me. And I wish you a very, very good conference. Thank you very much.
Awesome. Super cool to see Hugging Face on. I remember about 2.5 years ago, I went to NLP seminar, and they were talking about, I think it was like multi-language modeling that they were training, and somebody in the audience said, "Oh, have you loaded this model on Hugging Face?" And at the time, I didn't know what it was. I said, "Hugging Face, what is that?" I looked at the website, and I saw this icon right here on the bottom right, and I said, "Hugging Face, this looks kind of absurd. I'm not sure. It just looks different. I don't really know." And then 2.5 years later, Forbes magazine, Bloom, everywhere you look, it's there.
Yeah,
We're talking about image recognition, audio. It's not just NLP anymore. And before I knew nobody who used Hugging Face. And now anybody I talk to, whenever they get a model, the first place they go is Hugging Face. So it's crazy how much Hugging Face has skyrocketed. So yeah, thanks, Julien. And I think we got to get to questions because I'm hoping people in this audience have questions. Who has questions? Because if you don't, I will think of some. There.
Oh yeah, there we go. Oh, I forgot to say. So I'll be here today. We'll have another session. So we'll have a deep dive code session this afternoon. If you want to join that, we'll do NLP, and it's going to be code only. So yeah, you can ask your questions there if you want. Please.
So thank you, Julien.
Sure.
I know nothing about ML or NLP or anything
I don't know
that
much
you talked
either,
about.
so that's fine.
But what I do know is team collaboration. So what you showed us was from your point of view as a single developer. But how does team collaboration work on your platform and with your tools?
Okay, that's a really good question. Yes, so obviously, until I clone myself, it's difficult to do collaboration on stage. But yes, this is one of the main reasons why developers and companies use the hub as well. Of course, you can do this like transactional work, like I'm doing. Grab a model, train it, push it back, etc. But if you're in a team of machine learning developers, and even if you have multiple teams, it's super convenient to use the hub as the place to share your artifacts, right? And everything I showed you today is public, okay? All my models, all my data sets. But we also support private models, private data sets. Okay, we have this concept of organization. So we could have, let's say, a PyCon Sweden organization, and they could share their own models and data sets privately, okay, and collaborate on that. And we have actually a lot of users and companies who do that. So yeah, it's the key, right? It's having this central place to discover models, share your models, and the only way you can get 83,000 models, and it's growing at a crazy rate. I mean, it looks like we get another 500 every day at the moment. That's kind of the speed we have now. It's because people are sharing, right? Somebody finds an interesting model for, I don't know, summarization, and then they have a really cool Swedish data set. And well, they want a Swedish language summarization model, so they go and train it, and they're happy with it, and they share it there. And some other developers will discover that. But yeah, that's why that push to hub API is so important to everybody, because sharing is just one line of code away. So it's so easy to do, right? And we really encourage everybody to do that, right? And if you're not too sure, keep your model private, and that's fine too, right? Zero.
I said, what is the cost model of using Hugging Face?
So Hub hub usage is completely free. Okay, so storing data sets, pooling and storing models and data sets, that's completely free. The inference widget, which you saw, is free. We have also have a free tier for inference, which we call the inference API. Works pretty much the same as inference endpoints, except you don't get GPU acceleration. That's free as well. So all that, I would say, core set of features is completely free. AutoTrain is a paying service, although unless you add a ton of data to it, you can use it for free, right? It will give you a cost estimate. I forgot to show you, but before you click on the "Okay, train that stuff" button, it gives you a cost estimate. So a lot of times for smaller data sets, it's going to be completely free. And inference endpoints is a commercial service, but again, if you use CPU, you saw the pricing there. If you use CPU, it's pretty cost effective. But generally, yeah, you can use Hugging Face completely for free, as just like you would use GitHub, right? It's kind of the similar story. We have other ways of making money, which are not evil, by the way. So, yes. Oh.
Thanks for the great talk.
Sure.
Of course, machine learning is a difficult subject, but you've succeeded in making it more pedagogical. And what has your strategies been to create these sort of resources and documentation, and how did you succeed in educating about this difficult subject?
I think it's quite simple. You have to understand who's your audience, right? Which is the question I ask myself every single day. And of course, initially transformer models were adopted by experts, okay? Because, they keep a close eye on the state of the art, so machine learning engineers, data scientists, researchers, and that's how, I guess, Hugging Face started, okay? But even then, those expert users found it difficult to use the models. I remember when BERT came out, I rushed to GitHub, and I was like, okay, so this is supposed to be a great model. Great, okay, I'll trust you on that. How do I use it? And, I was like totally dumbfounded, reading the GitHub instructions and like, okay, there's a fine-tuning script, but I'm not sure I understand how it works. And I just want to predict, how do I use this thing? How do I test it in 2 minutes or 2 seconds? So even for experts, it was difficult. And I think that's why the rise of that Transformers library is so spectacular, is because you saw it, right? It's most of the time it's one line of code to download and one line of code to predict. So you can't make it much simpler than that. And that's really our obsession, whether you're an expert or whether you're just discovering Hugging Face today, we want you to get to work quick. Because at the end of the day, machine learning doesn't matter, those models don't matter. It's about the idea, the creativity, the problem you want to solve, and figuring out quickly, is this a model that can help me get there, yes or no? Okay? And how do I validate that in an hour? Okay? Then, sure, at some point, if you get 90% accuracy and you really need 92 or 95, okay, there's more work, and you can probably get help from more skilled users to get there. But you should be able to go quick on your own. So whether it's the Hugging Face course, the Hugging Face documentation, which I think is really good, and I can easily say that because I'm not writing it, but it's great. The APIs, everything is built with that in mind. If it's 3 lines of code, how do you make it 2? If it's 2, how do you make it 1? And how do you make it simpler and with reasonable defaults and simple settings, so that even a normal developer, and I always mean that in the most respectful way, I consider myself I guess a less than normal developer, less than average developer. How can they use that stuff, right? And stable diffusion in 2-3 lines is amazing, I think, right? And that's how we want to. That's how we want to do it, like simplify, simplify, simplify. And if the experts want to go deep, they still can, okay? They can load those models in PyTorch and go totally crazy with them, and they do. But for everybody else, 2 lines of code is good enough. Oh, yeah, over there.
We have time for one last question.
Okay, sure.
Yes, hi. I wanted to ask for your view on use cases where you have to provide you have the multilingual world. So maybe an organization is getting in data, different languages. So how does the Hugging Face platform support somebody who needs to build models, and ideally those models would be performing equally?
Sure.
Yeah, so kind of the multilingual enterprises or organizations that have that challenge.
Okay, yeah, that's a really good question. So actually, let me go back maybe here. A lot of those really popular NLP models are trained on multilingual datasets. Okay, and generally we support quite a ton of quite a few languages here. And whether it's NLP or speech to text, etc., you'll find that a lot of those models are trained on at least, I would say, the main European languages, and sometimes much more than that, right? And that's important because not everybody speaks English, and of course, if you want to, let's say, classify support emails in an enterprise that serves 25 European countries, well, I don't know how many languages you need to do that, but certainly more than English. So those models are trained on that, and it's also important because the more languages you have, the better the models are generally. If you train a model on English and German and Italian and Swedish and French, etc., you end up having a stronger model than if you only train a model with English. Okay. And that's a fact. For example, the big science project which we were co-leading built this Bloom model, and Bloom is an open alternative to GPT-3, right? So if you don't want to go and pay lots of money to OpenAI for GPT-3, go and use Bloom. It's free. And this one was trained. I'm quoting from memory. I think it's 43 languages, 43 or 46. I never remember. And including, I would say, less spoken languages from different parts of the world, because you just end up having a better model. And then, of course, maybe your use case doesn't need 43 languages, and you can fine-tune on 5 languages, but you start from something that's super solid because it has learned so many different representations. So most of those models are multilingual, actually, and we also have multilingual data sets. So go and try them out, and if you don't find the support there, then go and find a data set, fine-tune, and share. Okay? Let's get to 100K models. All right, I think we're out of time. Yeah. Well, thank you again. Thanks for the great questions, and yeah, we can continue afterwards. Thank you.